Yes, can you hear me? At least message करके please reply करो so that we can start our session. Is my screen is visible? Can you please let? Yes, can you see my screen? Yes, can you see my screen? Can you please let me know? Is my screen is visible to all? Okay, yes, yeah. Okay, so we'll start the session. I will revise fastly what we covered up to this part, and then we'll go for the part. So we started with unit number 1. In unit number 1, this is our syllabus. 2-3 students, they already asked me, sir, is our material, what are the contents are there, it is sufficient? So I covered all the stuff as per your syllabus. Okay, I don't have an in-same paper with me. If anyone is having a paper, please you can share with me, so that within what we can say, within a span of 3 to 4 days, we'll also discuss that paper. But all the things which is there in syllabus, I try to cover. So in the very first lecture, we covered about the definition of data science and the big data. Then we covered the different types available for data. And in the last lecture, we started with the data science process. So what is the process while dealing with the data science project? Okay. So already we discussed all this stuff in the very first lecture. And in the last lecture, we started with this part. So this is a very, very important diagram available. I already told you that I have taken this diagram from this source, your web source we have. So it is 360digit.com website is there. And in that, they provided the mind map. In mind map, they explore everything in much more detail. So this is the, what you can say, overview, which is available for any data science project. But it is not like that. We have the different verticals in data science, like we have deep learning, we have artificial intelligence, we have NLP also. Now currently we also have the Gen AI, and we have the machine learning. So whatever the diagram or whatever this chart is available in front of you, basically it is there for machine learning. For artificial intelligence or for deep learning, we have certain changes. But currently, as we are talking about the normal data science part, so we will discuss something related with your machine learning part. So that part we are calling it as CRISP MLQ. The CRISP MLQ stands for Cross Industry Standard Process for Machine Learning with Quality Assurance. This cross indicates as we are dealing with a multidisciplinary activity in case of data science. That's why they use the word cross industry standard, and we have the process here, and that to be this process is there for machine learning. Little bit models or little bit, what you can say, no. Yeah, is my screen is visible now? Please let me know. I'm also watching it on my mobile, so I found that my screen was not visible. Okay. Okay, so we are talking about the machine learning process, and this process here we are also dealing with the quality assurance part. So these are the important 6 blocks we have in your in the same exam. If you ask me, they will ask this individual blocks separately, or they will ask you the question, explain the data science process. See, in your for in same exam, if the question, most of the time the question may be there for 5 marks. So if the question is there for 5 marks, 10 points are sufficient to write. But if they're asking a separate question on business understanding, then you have to write a 10 points on business understanding. So I'm covering the entire stuff related with that. If they're asking a single question on any point, you can write minimum 10 points with respect to that. Okay, na? So we started with the business understanding, data understanding, and data preparation. Up to in the last class we covered up to this part. So what is the business understanding? So basically, when we are dealing with the business understanding, at that time we required a domain expert or we required the business analyst. Those who are understanding the business and those who are explaining that business to the data scientist person, so that they can start developing the model based on the given business idea. So there we discuss all this part in the last lecture. We should have business objective, we should have business constraint. Based on that, we are going to generate the project charter, which is the first document available for any project. After business understanding, the next part we covered is nothing but data understanding. In a data understanding, we have two blocks. One is our data type, another one is nothing but data collection. So what happened in data types and data collection, this also we covered in much more detail. So in data types, we have a continuous data type, we have a discrete data type. Next, we have a data type based on a qualitative data and a quantitative data. In a very first lecture, we covered that part. In qualitative, we are having a categorical data where we are having nominal data and ordinal data. In quantitative, we are having a interval data and we are having a range data. Okay? As well as we also have a data in terms of structured, semi-structured, non-structured. We also have a big data versus non-big data. We already covered related with the big data. We required 3 V's there, which are describing the big data, and non-big data, we have a little bit small data in that case. We also covered a cross-sectional data, time series data, and the panel data. In cross-sectional data, we have a time variable and we have a multi variable there. In time series data, there is only one variable which is going to change with respect to time. And in longitudinal data, we have a combination of both. Then whatever the data we have with us, that might be balanced, that might be imbalanced. But generally in industry, whatever the data, whatever the projects we have, in most of the cases, we have a imbalanced data. So what is the meaning of imbalanced data? That part also I discussed. Suppose you have a loan approval part, then in that case, it might be possible the 80% part, if it is approved loan, and for 20% the loan is not approved, it is an imbalanced data. Generally, it is expected we have a 50% approval loan and 50% non-approval loan to have a proper processing on that data. But ideally, if you go in an industry, you will be having a structure like this. So this is an imbalanced data. So how to deal with the imbalanced data, that part also we covered in the last class. Okay. Next, we covered about the offline data or batch data and the live streaming data. So these are the concerns related with the data types. Next, we covered about data collection. So when we are collecting a data, we require different sources. So generally, we have primary sources and secondary sources. Primary sources, we are directly taking a data from it. Like we are doing a different survey, we are doing the web scraping. And in secondary data sources, we are collecting a data from certain, database management system. Okay. Then for to deal with this data, we also required a data version control like GitHub and all this stuff we have. In data description, we should specify the data type of the different fields, different features. That part we are calling it as a schema. And we must have the clear understanding of data requirements, and that to be whatever the data we are receiving, that data should get verified. So in this way, this different stuff we covered related with that part. So the next part, so this was something related with your first part where we are dealing with the business understanding and data understanding. Now we are moving toward the second part, which we discussed in the last class, which is related with the data preparation. This data preparation block, it is divided in a 3 part. Student, just try to understand this thing. You might be observing that there are only blocks are there. Actually, in unit number 1, basically they want to understand the entire process. In industry, one data science project or one machine learning project, it takes around 6 to 8 months. So whatever the different blocks I am showing, that blocks, they have inbuilt, very depth understanding. But we'll not go in that much depth, at least in unit number 1. But when we'll move towards unit number 3, 4, at that time we'll try to understand how we are using a exploratory data analysis, how we are using a feature engineering and all the stuff. So the second important process available for your machine learning or for data science is the data preparation. Data preparation, this phase is divided in a 3 part. We have exploratory data analysis, which is also considered as a descriptive statistic. Second, we have to clean our data, whatever the data we are receiving, that we have to clean it, or we are considering it as a data preparation. So these are different names are there. And last process is the feature engineering. So we already covered about EDA part. In EDA, we have the first moment business decision, second moment business decision, third moment business decision, fourth moment business decision. We also represent our data in a graphical form as a univariate, bivariate, and a multivariate data. And currently we are having new libraries which are coming, which are performing EDA part automatically. So we have some auto EDA library. So this all the steps we already covered in detail in the last class. I will not go in detail about this part. If you have any queries, you can ask me. So we'll discuss this part on a group. Okay. So we already covered this stuff in the last lecture related with the EDA part. So the first part we covered related with the EDA. Now we are talking about the data cleansing or data cleaning. So in data cleaning, we have to perform these different operations. That we have typecasting, we have handling duplicates, we have outlier treatment, we have a zero and non-zero variance feature, then the discrimination or grouping or binning. Then we also have to deal how to deal with the dummy variables, how to deal with the missing values, why we require transformation. So when we are having what we can say the skewed data, right skewed or left skewed data, then at that time we should go for transformation like log transformation. Then we also have a feature scaling part. So feature scaling, why we required. So in most of the time, just now I given you the example. Suppose my y, it is output which is f1 x2 plus f2 x3. In this way, if you have the parameter, f1 multiplied by 2 and f2 multiplied by 3. Now, if you see this part, f1, if I am considering it as an income, so we know that income value is a 5-digit value, and if you consider it as age is a 2-digit value. So if you take the calculation here, the most weightage will be given to whom? The weightage is given to the f1 feature, as the f1 feature is having a more value. So to avoid this discrimination between both this feature, what we are doing, we are converting this f1 in the range of 0 to 1, or we are converting this age again in the range of 0 to 1. Now, both are in the same range, so they will provide the equal weightage to decide the value of y. That is the basic idea behind doing your feature scaling. Okay, so this part we covered, and after that we started with the feature engineering. So we have a different data, like we have temporal data. Temporal data is a data related with the date and data related with the time. We also have a numeric data, we have a categorical data, we have a text data. Now currently, as we are dealing with the NLP as well as GenAI, we have to deal with the text data, and lastly we also have a image data. So deal with the image data, basically the CNN part is used, which is a part of deep learning. In text data, now currently we have a LLM and all the different stuff. In GenAI part we have, and for categorical data we are using one-hot encoding. That then we also have the what can I say, nominal encoding, and then we have the ordinal encoding. This stuff you already covered in the last class. Okay, so this stuff we covered in the last class about all the stuff. And lastly we have feature extraction and feature selection, extracting the feature. So in most of the cases for feature extraction, we are using what? PCA part, principal component analysis. This PCA part, basically it is providing the proper extraction of the feature, but the explainability part is missing. So in your project, if the explainability is not there, we should go for PCA part. Otherwise we have different methods by we can do the feature extraction. Okay, so this stuff we covered in the last lecture, which is related with the second part, that is data preparation. Now we'll move towards again third part. So we have seen up to this part number 1, business understanding, part number 1A, 1B, data understanding, and then we covered about a data preparation. So I think up to this part, if someone asks you the question, you can easily write down this. Today after this lecture, I will share the entire presentation with you. Now we'll move towards, today we'll see, today we'll try to complete this unit. So just we are having model building, evaluation part, model deployment, and the monitoring and maintenance. Okay, so we'll try to cover this part, and only one part is there after this, that is machine learning definition and the relation of machine learning with the data science. So we'll try to complete this part today itself. Let's see how time permits us, otherwise we'll continue tomorrow. Okay, so we'll start with the next part, that is a model building. So before model building, which processes we perform? We perform the business understanding, data understanding, and data preparation. So after data preparation, now your data is completely ready. We can select any model and we can pass it to that model, and we can generate or we can train our data. So in model building, what we have, model building basically that we are calling it as a machine learning, or it is also considered as a data mining. In this case, we have a different algorithms. Like here we have the supervised learning algorithm, we have unsupervised learning algorithm. In some cases we have self-supervised, which is also called as a reinforcement type. In some cases we are also dealing with the forecasting of the weather, we can say it as a, right. So generally there we are dealing with the time series data. Now what is the difference between supervised learning and unsupervised learning? Anyone is having any idea? Kya hota hai supervised and unsupervised? I think by the name we must clear with this idea. Supervised learning, what we have in supervised learning? In supervised learning, the target is present, the Y part is present. So you might be having a different features like F1 feature, then you will be having F2 features, then you will be having F3 features. In this way, you have multiple input features. But at the same time, we also have the y you can consider as a label, or you can consider it as a output. So generally they are providing output with us, and based on that we are having supervised learning. In supervised learning we have a multiple algorithms that we'll see when we'll move ahead. The name supervised is that we are comparing our input always with the output, and we are trying to find the pattern, or we are trying to find the relation between y with respect to f1, f2, f3, and if you have multiple features in this way. That's why it is considered as a supervised. The next example, so in supervised learning, if you want to say the most popular problem is a regression problem, and next one is a classification problem. And in industry, most of the part which we are using currently, they are talking about, or they are dealing with the classification part. So these two problems are there when we are dealing with supervised learning. Now we are going for a next part, which is unsupervised learning. In unsupervised learning, most of the time we are dealing with the clustering. So what is the meaning of clustering? We are combining the data points which are having similar characteristics. In clustering, we are combining the data points which are having similar characteristics. So here we have a different algorithm that again we'll see, because our unit number 3 onwards we have to deal with this part only, supervised learning algorithm and unsupervised learning algorithm. Okay. And in time series data, just now we discussed about time series data. So time series data is different than this, because in time series data t is playing a very important role. So with respect to t, we are going to see what is the changes in our feature, and that is nothing but a time series. So in time series, t is an important factor we have. So all this stuff, they are coming inside this, and as well as we also have a self-supervised learning, which is also considered as a reinforcement learning. In that case, basically we are using a award and reward, and we can say it as a punishment. Okay. So if some what you can say algorithms, they are giving award, the weightage are get changed with respect to award, and if there is certain mistakes, and then at that time we should get a punishment. So in this way the model is get trained. They are the self supervised algorithm, but industry generally whatever that reinforcement part is there, currently very less projects are there related with that, but in research majority of work is going for related with the reinforcement learning. So these are the steps related with this. We'll see in detail about that. So how we are performing the, what we can say, supervised learning. So in supervised learning, basically the first job we have to perform, that is nothing but we have to split a data. Just now what I said, suppose now consider one case. Now I want to check whether the loan is approved or not. Approved loan. I will take that example. And for that I will take, suppose, first feature as a age. Then second feature might be your interest rate. Okay, interest rate. And third feature, suppose I am considering it as a CIBIL score. For India, if I am going for, I will consider as a CIBIL score. And based on that, I will decide this Y, which is nothing but my output, or which is my label. So you will be having certain value. Suppose one person is having age 30, the interest rate which we are giving for that is suppose 6%, and the CIBIL score, the higher the CIBIL score, we will get a greater value, right? The CIBIL score, I think in the range up to the 90 for India. Currently, I do 900. Currently, I don't know what is that, but we will have some value. Suppose I will consider it is, we are having a value as a 500, and then we will decide whether we can approve it or not. So we have a historical data. In that, we will suppose I am giving it as a Y. So in this way, I have more records. For that, you might be having value Y, or you might be having value N. In this way, we are having a data. So what we are doing, this data, we are splitting it. What is the meaning of splitting? Suppose I have total 100 records with me. So generally in industry, what they're doing, so the general practice is that you should have 80% data for training and 20% data for testing. What we are doing, the 80% data we are using for training and 20% data we are using for testing. What is the meaning of that? If I have 100 samples or 100 records with me, or 100 rows with me, out of that 80 record I will use for training and 20 record I will use for testing. So for testing I have 20 record. Now what they are doing, the training part is again divided into two more parts. One is a training part, another one is a validation. So whatever the training data we have, again for that data we are using 80-20 ratio to do the validation. So what is the training data? It will come, suppose we have 80 samples, out of that we are using what, 80 divided by 100. So this value will come as a 64. So 64 records we are using for training And out of 80, the remaining 16 records we are using for validation, and we have a 20 records which we are using for testing purpose. In this way, we have the distribution, or we are splitting our data. Okay, the training data we are using for building the model. Whatever the machine learning models we have, we are building that machine learning model on a trained data. The validation data we are using to check whether the model is properly trained or not. So we are testing on our validation data, as well as here we are also changing some hyperparameters. Hyperparameters are nothing but the some extra parameters by which we are trying to improve our accuracy. And by doing the auto hyperparameter tuning, basically we are what you can say improving our accuracy or improving our performance of the algorithm. And after this, we are going for a testing data. So whatever the data we have, we are going to test that data on a model which is designed by using a training data. Okay, and we are also having some of the training error. So how we are getting a training error and all the stuff we'll see when we'll go ahead, right? So we have the bias error and the variance error plus irreducible error. Bias error means the error at the training time, and the variance error is nothing but the difference between the error at the training and as well as the testing. So what we required here, the bias error, it should be low, and the variance error, it should be again a low, to have a proper, what you can say, output. Okay, so this is something related with that part. Okay, so in which we discuss about supervised learning, where we are dividing the data. Now in unsupervised learning, we have a different algorithm. Just now we say we have the clustering algorithm, we have the dimensionality reduction algorithm. There some associative rules are also there. Association rules. Now this is again an important concept we have. What is the meaning of association rules? Now you might have seen that when you will go in a DMart, at the entry part, they are keeping some, what you can say, cold drinks or some biscuits and all the stuff, right? As well as if you go in a market, you might in a DMart, you might have seen if you have some milk products, right? Like if you are going having a bread, near a bread, you will get the, what you can say, milk packets, because there is an association between milk and bread. Okay, so we are doing certain association. Mean the while keeping the, what you can say, objects in that DMart, they are keeping in some association. Okay, if you are going to buy a pencil, at that time you will also get the eraser there, you will also get the compass there. In educational department, we have all the stuffs related with the educational part. Notebook is there, books are there, so all the different stuffs are there because they have association with them. Okay, na? So it is like that. Next, we are having a recommendation system. Now I think everyone knows about the recommendation system. You might be using a different what you can say, OTP platforms, right? Even on your YouTube also, if you see the video related with the data science, next time when you go and search on your YouTube, you will get a max, what you can say, video related with the data science, the topic which you are searching. So they are using a recommendation system there. The same thing happens with your OTP platform. You might be observing that you are watching some, if you are watching some comedy movie, right? If you have watched 3-4 comedy movies, then your app, it will recommend you some of the comedy movies. So that's a part of a recommendation. Okay, na? And some of the algorithms we require the network analytics. There we are talking about the graph tree. This stuff is there. And next is a text mining, where we deal with the NLP part, right? So we have these different steps related with the unsupervised. In unsupervised, we are not having output, or the label part is missing. Just this is important. In your exam, they might be asking a question, the difference between supervised and unsupervised. So you must know the supervised, nothing but the labels are present. In unsupervised, labels are not present. The output is not there. Only input is there, and based on input, we are either doing clustering or we are doing a segmentation. Clear? And these different algorithms are there in your unsupervised, and in supervised, we have the algorithm like regression and classification. Okay, na? So in this way, we have it. Okay, up to this part, anyone having any issue? Please, if you have it, please let me know. Or can we go ahead? Yes, at least type something if you are unable to speak. Okay, clear. Okay, we'll go ahead. Okay, thank you for response. Yeah, now in supervised, so we covered about unsupervised one. In unsupervised, this much algorithms are there. Now we are talking about supervised. What is the meaning of supervised? Labels are present. Labels come, the indirectly it is considered as a y. Generally, in case of machine learning, labels are considered as a y and inputs are considered as a x. So you will be having a different inputs like x1, x2, x3 in this way. and we'll be having most of the time we will be single level, which might be, if problem is regression problem, then in regression problem you have, see here it is written, regression problem, the output is nothing but your continuous value. Output is what? It is continuous value. What is the meaning of continuous value? I will say, give you the example of regression problem. That regression problem example is prediction of house price. Prediction of house price. This is the example available on a regression. Now, what is the prediction of house price? So there they will be providing a different what you can say features, like suppose currently you are living in Pune. So in Pune, if you live in the center of Pune, then definitely house price is more. If you live outside the Pune, definitely house price is low. So the area plays an important role. So they will provide the different features. Based on that, we have to decide the house price. So this house price value is a continuous value. It's not like a character, like just now loan is approved or not, yes or no. It's not like that. So if you have a output which is in terms of continuous value, that is nothing but a regression model. There's another example you can you might be knowing, you might have seen that Car Dekho app, right, on which we are observing a car and then we are purchasing the car, where we are going to predict the price of a car based on the model, based on the year, as well as how much kilometer it ran. So there are different factors we have. Based on that, the price of car is get predicted on that car Dekho and the different apps. So these all problems are what? Regression problems. Now next is in industry, most of the problem we have in terms of classification problem. Now what is the meaning of classification? Just now what I said, loan is approved, yes or no. So it is what you can say binary classification, where there are two classes are there. But it might be possible you have more classes. Like suppose I am giving I want to give the movie review. So movie review might be neutral, it might be positive, it might be negative. So as we have the three outputs, right, so it is your it comes as a multi variable or multi-class problem. So in this way we have the classification model and the regression models. Most of the models are coming inside this. Then we're also having some shallow machine learning models. Okay, but these shallow machine learning models, they will be again as similar as that of our classification model. Then in ensembling model, so in ensembling model basically we are combining two or more model to improve their performance. So most of the time in ensemble model, they have the bagging and boosting, these two techniques they are using, and by that they are trying to improve the performance of model. So if you combine more than two models, then at that time the performances get improved. That is the ensembling models we have. As well as we also have certain models where we are dealing with a black box. So black box means we provide the input and we'll get the output, but what happens inside that we are unable to understand it, right? This type of a model they are calling as a black box technique or black box model. Okay, generally in deep learning, in most of the model we have in a deep learning, they will be like this black box techniques. Okay, okay, so this is related to the supervised learning. Now we are talking about the forecasting or a time series. In this we have some two types of model. One is a model based approaches and some are the data driven approaches. So we can do weather forecasting. We can also do this if some seasonality. You might be knowing about the e-commerce platform, right? If certain what is say festivals are coming, at that time they are providing certain sales to us. So this is based on which data? So they are doing the forecasting that suppose currently now Rakhi has been gone, right? Just on the Monday there was a Rakhi. After what you can say 1-2 weeks we have the Ganpati festival. So the e-commerce company, they know that as there is a Ganpati festival, there is a certain what you can say certain equipment or certain components, those who are having a lot of sale. So at that time they will come with that part. So it happens, the Ganpati festival mostly it comes, everyone knows it comes in August and September. So this series, it is coming inside what you our time series part, time series data part. Okay, na? Like so in this way we are also doing a forecasting, the how if your company it is having a positive progression or if it is having a negative progression, forecasting of weather, forecasting of your this stock price prediction, you might have heard that. So these different steps which are coming inside it, and in this way the model building part is get completed. Is it clear what is there in this model building part? So model building part, it contains supervised learning algorithm, it contains unsupervised learning algorithm, as well as it contains the forecasting or the time series part. So we'll cover all this part in detail. We'll see all this algorithm when we'll go for the next part. Anyone is having any issue up to this part? Yes, can we move ahead? give response so that we can go ahead. If you have any question, please let me know, or even if you have that question later on, you can ping it on our group. I'm providing my number in this slide. Also numbers are there. I will share this slide after the lecture. Okay, so I'll move to the next part, the fourth part, which is related. So we covered which part we covered up to this part. We covered a business understanding, data preparation. Now we build the model. So after building the model, we must check whether your model is performing properly or not. If your model is not performing properly, then there is no use of designing such a model. So how you can understand model is performing properly? For that you require some evaluation, or we can consider as a performance parameter. So evaluation is considered with a two part. One is nothing but the model accuracy measures, how good your model is performing, that is given here, as well as if your model is not providing your 100% output, then there are some errors are there, right? So which type of errors are there, that we have to understand it. Clear? So we'll see what is there inside it. So now when we are talking about a model accuracy measures, we are having output which might be continuous, which might be discrete output, as well as we are having certain statistics conditions, like we have Gini statistics, then we have the Kullback Leber divergence, as well as we'll have the alkaline information criteria and kappa. So these different statistics methods we are having, by which we are deciding the model accuracy. And as well as we are also having the evaluation matrix over here. So for classification matrix, we have accuracy, we have F1 score, we have precision, recall, right? Then we have AUC ROC curve. For regression based problem, we have the mean square error, mean absolute error, right? Mean percentage error. So there are different evaluation matrix are there. Based on that, we are deciding whether our model performs well or not. Okay, this is the first parameter. Second parameter, we have error functions. Okay, so what is the meaning of error function? If you are considering a single row, then single row error is considered as a loss function. And if you are having the entire, if I am having 100 data points or 100 rows, if I am considering the loss of every point and then I'm averaging it, it is considered as a cost function. Okay, then how we are calculating a error? Basically, error is nothing but 100% minus whatever the accuracy you are getting. That is the error percentage we have. So for that we require a fitted value and predicted value. Fitted value means it is a value which is already present, and predicted value means after training your model, whatever the values we have. So we'll try to compare both with each other, and then we are deciding the accuracy part. Okay, in the same manner we have the error and the residual part. This is something which is related with the error functions. Okay, so both this thing, model accuracy measures and error functions, they are describing our evaluation part, which is the fourth part available for our data science process. Now after evaluation, I have the proper output, I have my model is properly trained, I'm also getting the expected performance. So we have to go for a next part, which is nothing but the fifth part. We have to go for a deployment of a model. So we should launch our model on a, what you can say, cloud. So what is the requirement when we are going for this model deployment, that we'll see. Okay, so what happened in model deployment part basically? Yeah, so when you are deploying the model, you should have certain things with you, which resource you require. Like now I told you in a very first lecture, generally model deployment, this part, it is done by the MLOps, which we have. They are using three popular cloud services. They might be using Amazon Web Services, AWS. They might be using Azure. Azure is given by our Microsoft, and they might be using GCP, Google Cloud, this thing, processing. So GCP is by Google, Azure is by Microsoft, and AWS is by Amazon. Okay, these three web services we have by on which we can deploy the model. So while deploying the model, we must know which resources we require for our model, which type of server you require for your model, which hardware you require, and which software you require. All this stuff you must be aware of that. And based on this, we can select the AWS, Azure, or GCP. Based on this, we can select the price, because the price is also important issue when you are deploying the model. Clear? So that's why if these things are clear to you, then we can decide whether we have to implement it on AWS. In AWS, we are having a EC2 instance. And by this, we are deploying the model. Okay, in Azure and GCP also we have certain services. Okay, so in this way, these four parameters are playing a very important role when we are deploying the model. Okay, now after deploying the model, this is the stuff which we have to consider, that we have to plan for regular monitoring and maintenance. Basically, it was our last step. So after deployment of your model, it might be possible your model is performing well for certain amount of time, but after certain amount of time, the data may get changed. Like everyone knows, right? Before COVID, things were different, but in a COVID, what happened, as there was an entire lockdown, so the job of many people they have, or the job has been taken away from them. So because of that, what happened, they were unable to pay their loans, they were unable to pay their interest and all the stuff. So the entire system is get collapsed. Because of that, the data part is also get changed with the banks. So some banks, might have reduced their interest rate only for that COVID duration, and again after COVID they have came on the proper track. So because of that COVID part, what happens, suddenly the model or the performance of that model goes down. After COVID, it will again come on a track. But the moment it was down, then at that time we should again go for monitoring the model, and we should again change the parameters of the model. So it's very, very important. As well as it might be possible after certain duration because of a data drift. Data drift is nothing but the change in the data. So while training, we are using some other data, and for testing, we are using some other data. If this thing happens, if there is a large variation in the training data and the testing data, definitely we will get a less accuracy. So to get, but we are expecting certain higher accuracy, and for that, again, what we have to do, we have to do the monitoring and maintenance. So this is the important process we have it. And because after every monitoring and maintenance, after every iteration, we'll check the result and their validity. Okay, so we should also decide this all the stuff. When our model is going to retire, when we have to replace our model, in which condition we have to replace it, in which condition we have to update, all this strategy we have to specify when we are deploying the model. Okay, so this is the fifth part we have it. And now we are coming toward the last part, which we discuss currently, that is the monitoring and maintenance. Why we require monitoring and maintenance after deploying your model on a cloud? Generally, we may feel that now our task is over, right? But it's not like that. We have to do the monitoring. Why we require monitoring? Because the thing is that it might be possible because of a change in your data, your model will not perform well. When you launch the model, so for 2-3 months it might perform well, but after certain amount of time, it accepts the new data which is not on which you have not trained it. So at that time the performances get reduced, but we should, what you can say, increase the performance. So why we require monitoring and maintenance? They entirely provide the information here. Degradation of a performance over a time, right? Everyone knows that before 10 years what was the data, and currently what is the data is there is a huge difference in that. Okay, so we should also have the when we have non-stationary data distribution, then again we require a monitoring and maintenance part. Okay, it might be possible after a certain amount of time our degradation of hardware is there. Everyone knows that currently even whatever the PC and all the stuff we have, after certain amount of time, this parameter, the RAM as well as the performance of CPU, it is get slowed down. So same thing happens with it. Then there might be some system updates are there, right? We know that the different what you can say softwares, they get updated daily, or they get updated after every 1 month or 1 year. So because of that, again we require a monitoring and maintenance. Okay, so there is a model drift also there, and yeah, so these are the part we have on which we should consider the stuff. Now there is a one concept of data drift here. They also mention it, drift and outlier. In the last lecture I already described about outlier. What is the meaning of outlier? Suppose I am considering as you all are in the third year, I given the same example, right? You all be having a range in the age in the range of 20 to 22, right? But suddenly if there is a one person who is having an age, suppose I am considering one small child who is having an age as a 4. So what happened? Generally all this thing, if you take the mean of that 20 to 22, I will consider the mean as a 21. So average or the mean age of the student is a 21. But what happened? There is one candidate who is having an age as a 4. By mistake, suppose instead of putting in a junior KG, I put it in the third year part. Then at that time what happened? Because of this, so this is we are considering as outlier. Ye ho gaya aapka outlier. But what is the drift? Drift is nothing but change in data. The entire data is get changed. I already given you the example currently when the drift may be possible currently because of the scenario of the COVID. Before the COVID, the scene was different, and just after 1 month when the COVID started, the scene was different. So this called as a data drift. There is a sudden change in the data, and that change is not controllable by anyone. It's not possible to control it by a simply certain model. We have to rethink on that, and then we have to perform certain operations. ठीक है? Is it clear? This part ये clear हो गया क्या? Right? Okay, so which different part we covered up to this point? We covered about the definition of data science. We covered the big data problem. Next, we covered the recognizing the different types of data, and we started with the data science process. What is there in data science process? So this part already we covered. This is the part. Just again, we'll revise this, and only last part is remaining related with this. We have a business understanding, we have a data understanding, then we have a data preparation. After that, we covered a model building, then we have an evaluation of that model. Next, we are going to deploy the model on a cloud, and lastly, we are performing monitoring and maintenance to check there is a drift in a data. Because of that, if model is unstable, we should make that model stable. Anyone is having any issue up to this part? Okay, I don't think so. You will be having any issue, right? If you have any issue, please ping me on a group. Now we'll move toward the last part of this unit, which is nothing but a machine learning definition and relation with the data science. So what is a machine learning part? Machine learning, this is an important word. Up to this point, what we are doing, or in a software, they basically what they're doing. So we are having a structure like this. We are providing an input. Okay, then we have certain program, and based on that, what we'll get output. This is the traditional approach which we are using in software engineering, but this is not the case when we are dealing with the data science problem. What you are doing in data science problem, initially you have an input, and at the same time what you have the output also. So आप input भी देते हो और आप output भी देते हो. Based on that, this program is get trained. You will get what? Training. Okay, or we will get a model, and on this model, what we are doing, we are applying a new data, and for that new data, we are trying to get our new output. So the important question, are you doing a programming? No, as such, you are not doing any programming. Yes, we are doing a programming, but that program is not there to identify the output. Basically, what we are doing, by using that training or by implementing certain algorithm, we are trying to identify the relation between input and output. After getting the relation between input and output, we are providing a new input so that we'll compare, we'll get some output. This is nothing but this is a scene available with data science part or the machine learning. But in the traditional, what you can say, IT part, we have in terms of input, then we are writing a program and then we'll get output. But here we are not writing the program for our input. We are having input, we are having a output. We're trying to identify the relation between both by training, and then after training we'll get one model, and that for that model we are passing a new data so that we'll get the new output. So this is the process we are having it in case of machine learning. So in a small way, if I want to define a machine learning, total 4 definitions are available. What is the first definition? Just try to understand it. Machine learning is a subfield of artificial intelligence. Everyone knows that. Okay, and that gives what it gives. It gives computers the ability to learn without explicit being programmed. Here we are not programming, right? Whatever the programming we are doing for our traditional IT part, that we are not doing here. Okay. Second definition you may give, out of this 4 you can write any definition. Okay. ML is a study of computer algorithms to improve automatically through experience and by the use of data. So we are learning through experience. Experience is nothing but the past data, historical data. Okay. Third definition, we have machine learning uses algorithms to identify the patterns within the data. Whatever the input data and output data is here, we are identifying the pattern within them, and those patterns are used to create a new data model that can make the prediction based on that product, that pattern. What we are doing, we are applying a new input so that we will get the new output. And lastly, we have a new one more definition. ML is an area of artificial intelligence with a concept that a computer program can learn and adapt. Okay, क्या है लिखा है यहाँ पे? Important one is a computer program can learn and adapt to the new data without human intervention. There's no interventions of a human in case of a machine learning. Is it clear? Are you having any issue with this? This is the definition of a machine learning. Okay. So we learn the definition of data science. We learn the definition of what this big data, and this is the next definition we have, that is a machine learning definition. And now the last part is that how we are correlating machine learning with our data science. This diagram, it is very, very important diagram. So we have the first part, that is a big diagram, big circle. which we are considering as it is a data science circle. The subfield of data science is artificial intelligence. I think in the very first definition you might have seen that the machine learning is a subfield of what? Artificial intelligence, that gives a computer the ability to learn without explicitly being programmed. ठीक है ना? So ये मशीन लर्निंग आपका आर्टिफिशियल इंटेलिजेंस का सबफील्ड है, और आर्टिफिशियल इंटेलिजेंस इज द सबफील्ड ऑफ आवर डेटा साइंस. Then inside artificial intelligence, we are having a machine learning part on which we are currently discussing this stuff. And lastly, we have a deep learning where we are dealing with neurons, okay, or neural network part is there. CNN, all the stuff is there. So in this way, what we say, the machine learning is a subfield of the data science. In data science, we have AI, we have machine learning, we have deep learning, we have NLP, all the stuff it comes inside our AI or the data science part. Okay, is it clear? Okay. So in this way, basically we are completing. Now see, I will again go to that part. So this is the end of unit number 1. I tried to cover all the steps here. Defining the data science and the big data problem, we covered that part. Recognizing the different data types, gaining the insights into the data science process. So the entire data science process is divided in how many parts? 6 parts. The first part is divided in 2 parts: business understanding, data understanding. Next, what we have the data preparation part. After data preparation, we have the model building part. Then which we have the after model building part, we are having the evaluation part. After evaluation, we are having the model deployment, and the last part is a monitoring and maintenance. So these are the steps which is required for any data science, what I can say, process or any data science project. And last part we seen, it is a machine learning definition. So we covered about 4 definition. And what is the relation of a machine learning? Machine learning is a subfield of the data science, right? So inside the data science, you will be having artificial intelligence, then you will be having a machine learning, and at the end you will be having the deep learning. So this is the entire stuff available for your unit number 1. So I will share this thing with you. Anyone is having any issue with this, so you can ask it. Otherwise, we'll stop here for unit number 1. From tomorrow, we'll try to start the unit number 2. I will share this presentation with you. Anyone is having any problem with unit number 1, so we can discuss it. Please let me know if you have any issue. Yes, Dia, you can ask.
Oh, sir, I don't have any such issues, but I wanted to ask you whether these PPTs will be enough for us to score in NSEM.
Yeah, easily, because I made the presentation in a such a way that I covered all the steps available in a syllabus. That's why I said I will also ask to ma'am also. If you have a INSEM paper, na, please kahin se milta hai to you can share with me, and we will see accordingly. But all the stuff, this is the syllabus we have. With respect to this syllabus, I covered the entire stuff. I don't think so they will ask anything beyond this. But what is there, as for INSEM exam, maximum questions are there 5 marks. So as it is 1 unit, I think you will be having question number 1 or 2. So in question number 1, you will be having 3 questions. In question number 2, you will be having 3 questions of 5 marks. So for that 5 marks, it is expected to write 10 points. Okay, na? So you try to now for this whatever the part is there, it's okay. I have a means little bit issue related with this part, this what you can say, data science process. So in that we are having total 6 major branches. So if they are asking the individual or the what is a common question that explain the data science processes, then all these 6 all these 6 you can write even 1 or 2 line, that's more than enough. But if they are asking in detail that what is the business understanding or what is the data understanding, so you need to explain that business understanding for 5 marks. So that's why I covered minimum 5 points inside it. So it's more than enough. You simply go for this. I don't think so they will ask any question beyond this. And if you write this much, it is the actual process which is followed in industry. So none of the part means you will not having any question beyond this. That's damn sure.
Okay, sir. Sure, sir.
Still, even if you have any question paper with you, na, you please share with me. We will discuss that part. Okay. And this is the end of unit
Sure.
number 1. Unit number 1 is easy as compared to that. Now in the from next class, within a 3 to 4 hours, we'll try to unit number 2. Unit number 2 is little bit what you can say. It is having some math background. So just by reading this, you can understand unit number 1. But for unit number 2, certain, I think, formulas and all the stuff is there. So we'll try to cover it. But for unit number 1, it's more than enough. Only provide me that insem paper if you get from some sources, then we can discuss that part also. There's no issue. Okay. Yes. Any other issue? Okay, so yes, we'll stop here then. Okay, na? So thank you so much for attending the lecture. Tomorrow again at the same time, we'll start unit number 2. Just within a 5 to 10 minutes, I will share this material with you. Okay? Yes. Okay, chalo. Thank you. Bye bye. Take care. Good day. Bye.